Hi guys, happy Tuesday. Today we're going to go ahead and talk about something called the natural base, which is E. So just like pi is a number, E is also a number. So it's kind of wild, but let's go ahead and see how this whole thing came about. Recall the compound interest formula. Now this is a formula that you would have studied in Algebra 1, and this is what the formula looks like. A is the ending amount. What is the balance? P is called the principal. How much money are you investing or putting into the bank? It's always parentheses, 1 plus. R represents the interest rate that you are being paid. You remember, you always want to take any percentages and turn them into a decimal. Typically, your interest rate is given to you as a percentage. So again, you would have had to turn it into a decimal. Now, N is the number of times that interest is added to your account. Now, N can be a variety of values. If it's annually, N would be a 1. Semi-annually, it would be a 2. Quarterly, N would be a 4. Monthly, 12. Daily, 365. So N represents how many times a year is interest added onto your account. Your exponent was N times how many years you kept your money in the bank. So again, this was something that you studied back in Algebra 1. But this formula right here is how they discovered the number E. So here's the scenario. Suppose that $1 is invested. So you drop off $1 at the bank and the bank's like, yo, we're gonna give you 100% interest, okay? So 100% as a decimal is 1. So you drop off $1, it's 1 plus 100% as a decimal is 1, N times T. And it says for 1 year. So if I multiplied it by 1, N times 1 would just be N. So what happens is this is your formula. If you invest $1, you're getting 100% interest and you keep it in there for 1 year. So when they graph this, you guys, check this out. This is what it looks like. And so remember, we did talk a little bit about that line called an asymptote. There is what's called a horizontal asymptote in this scenario. N is the number of times that it's being compounded, okay? So as the compounding increases, as it gets very, very large, going all the way to the right, you'll notice that it's getting really, really close to a line, but it's not touching it. That horizontal asymptote has a value of 2.7182818, and it keeps going. It is an irrational number, meaning that it never stops. There is no pattern to it, but this is the line that your curve would approach. And because this happened, they gave it a special name. It is the natural base E. So just like pi, E is a number. E is approximately 2.72. Super cool. Now, if you were to graph the natural base, the parent function is e to the power of x. Now, this is an exponential function because my variable is an exponent. That is one thing. E is always a base. So I'm going to go ahead and show you that before I go any further. You do have E on your calculator. Notice it's above natural log, which is what we're going to talk about in the next set of video or in the next set of notes. But if I want the E, you have to the second ln. But notice what happens. There is my number E. It is always a base, meaning that it's going to set it up and say, okay, e to the power of what? For that reason, e to the power of x is the parent function. Exponential function, when you graph it, it's a curve. Super cool. Okay, so it's all tying together here. The domain, if you notice, it goes all the way to the left, it covers 0, it goes all the way to the right. So your domain, the possible x values are all real numbers. Your range for the parent function, y is greater than 0 because it stays up above the x-axis. So just some properties of the natural base E. One thing, just a common misconception, when you look at E and how they typically show you the value, they're like 2.718281828. Now, when you look at only that amount, it looks like there is a repeating portion, but there is not. It is a true irrational number. What happens here is they round it off a little bit. So it is irrational. There is no pattern. There is no ending. What you are doing today is just a graphing day. You are getting a worksheet. The grids are already there for you. But one thing that I really want to make sure that you're comfortable with is how to calculate E in the calculator. So again, we're going to go back to XY tables just to practice. So on your calculator, we're going to go ahead and do an XY table and then we'll graph. It is an exponential function because the variable is an exponent. So we do have to make sure that we get a curve when we graph this, okay? This would be exponential growth because the base is bigger than 1. So again, tying it all together. So if I want to put in a -3, this is how I would do this, okay? Please make sure you pay attention. I don't want you to lose points on a calculator thing. So second natural log. So I have E. E to the power of x is -3 minus 2. Now I need to close it. So this says this is where the exponent starts. This is where the exponent ends. My exponent is the x value minus 2. Now it's plus 1, but you have to make sure that you close where the exponent ends. So if I go plus 1, if I'm rounding it to the 100th, this is 1.01. Now here's the deal. If you entered it carefully, all I need to do now is change my x from a -3 to a -2. So I can use that up arrow option, 1.02. Okay, so that barely moved. Now if I go ahead and I up arrow, I change the x value to a -1. Hey, big jump here, 1.05. Woo, that was a big leap. Now I'm gonna go ahead, delete the negative, change it so my x value is a 0, and I have 1.14 if I'm rounding to the 100th. Up arrow, I wanna go ahead and change the x value to a 1, so it's 1.37. And go ahead and up arrow. I end up with the whole number 2. And last but not least, I'm going to put in a 3 and I get 3.72. So this is what you're doing on your worksheet. Your worksheet are 3 problems like this. You need to fill out an XY table showing me that you know how to calculate a base of E in the calculator. Super cool. Then you're going to graph. I do have a grid provided for you. For us, we're just going to go ahead and draw it. Artistic time. Okay, I have to go to the left 1, 2, 3, and I have to go to the right 1, 2, 3, because my x values are going -3 to 3. Now here's the deal with this. I have 1.01, 1.02, 1.05, and 1.14. So it is a little bit crazy here. I'm going to maybe go by like 0.5s. So if I go 0.5, 1, 1.5, 2, 2.5, 3. And yes, I know this is going to be a little bit further than 3, but I do think it'll allow me to zoom in a little bit more because we have all of these values so close to 1. Okay, so if I go to the left 3, I'm up 1.01. So it's basically at 1, just a tish higher. Now the next one, 1.02. So it's about the same level, a tiny bit higher. Same thing here, it's 1.05. Now at 0, it's 1.14. At 1, it's getting closer to that 1.52. Hey, we finally broke out of the ones. And 3 is like way higher than this. So when you graph it, you do want to make sure that you do get that curve-shaped graph, and we did. Oh, there we go. Now it's on there. Okay, so this is what you're doing. We're going to go ahead and do one more, and then again, your assignment today is to do a worksheet, 3 questions, complete the table, graph on a grid, make sure it's a curve. Last question, and then you guys, I will let you go and work on your worksheet. So again, the big thing is you want to be comfortable. How do you calculate a base of E on a calculator? Okay, because that's a skill that you're going to need to know how to do. So second ln gets you a base of E. E to the power of what? -3, close it. Because now your calculator knows that the exponent is a -3. This -3 is not part of the exponent. So the only way your calculator knows that is by closing the parentheses when you are done with the exponent. If I go ahead and hit enter, rounding to the 100th, -2.95. Awesome. Now I want to change that exponent, so I can just go ahead and up arrow, change my -3 to a -2. I have -2.86. Awesome. Go ahead and up arrow, change the -2 to a -1. and it's negative 2.63. Hey, awesome. Delete that negative. Power of 0, negative 2. Nice. Up arrow, now I want a power of 1, negative 0.28. Negative 0.28. And last but certainly not least, let's put in that 2. 4.2. We got a round. 4.39. Okay, so that is part A on the worksheet. Part B is to go ahead and graph it. Hey, I have this whole bottom portion of the graph, so I'm going to do this. Go to the left, 3, go to the right, 2. Holy smokes. Okay, downwards I need to go 3, so 1, 2, 3. Upwards I need to go 1, 2, 3, 4, and make sure that I have room where I can go above that. So let's go ahead and graph, and the main thing you're looking for is to make sure that you do get a curve-shaped graph, because this is an exponential function. So if I go to the left 3, I go down just about 3. Left 2, oh, it's a little bit higher, not much. Left 1, it's about negative 2.60. Hey, I got a negative 2. Okay, so you can already see that it's curving. Go to the right 1, I'm down a quarter. Now 2, it spikes way up past the 4. So when I go ahead and I connect these points, you can see that you are getting that curve-shaped graph that we are looking for. And that is everything for this wonderful Tuesday. Enjoy working on your worksheet. It's a short one, only 3 questions. You got this. Guys, we only have a few more days left together. I hope you're doing well, and I miss you tons. Bye.